We all have an intuitive sense of what mixing is. But when you set out to design a system, it helps to have a more precise vision of what you're trying to accomplish. Understanding specific mixing duties will help define your goals, which are vital in designing the best mixing solution. There are several different types of mixing. Resuspending solids and preventing settling is all about getting the solids off the tank bottom, into motion, and keeping them in suspension. For many processes in wastewater treatment, this modest level of mixing is all that's needed to ensure the desired results are obtained. To create a homogeneous mix means that we have not only gotten all the material off the bottom of the tank, but have distributed it evenly throughout the liquid volume. Finally, to effectively blend and prevent short-circuiting, we must create a homogeneous mixture given a continuous inflow and outflow of fluid. Otherwise, the incoming fluid could pass quickly through without mixing thoroughly with the fluid that is already in the tank, or staying long enough to achieve the desired reaction. Whatever your mixing needs, a clear understanding of mixing duties will help you define the intensity of mixing you require. With that information, you can then choose the appropriate tool and settings for the job. Before sizing a mixer, you need to understand bulk flow. Bulk flow is the movement of the entire tank's content in a regular pattern. Creating bulk flow is the most efficient way to keep a tank mixed. Most tanks can support a variety of bulk flow patterns, but it's easiest to create bulk flow around the tank's longest axis. In this low rectangular tank, it's best to go on the horizontal plane as shown. If the tank is taller than it is wide, then bulk flow is most easily established vertically. Round tanks that are wider than they are tall are most efficiently mixed with bulk flow in their horizontal plane. Every tank shape has an optimal bulk flow pattern. The designer's challenge is to determine how to create that bulk flow reliably, using the least amount of equipment and energy. Bulk flow is also important in special applications, such as oxidation ditches. With oxidation ditches, the designers of the ditch define the bulk flow, but there are still many considerations related to a mixer's distance from the bends, and its distance either upstream or downstream from aeration grids you'll need to consider. In these cases, it's best to consult a biological treatment expert from a trusted source, like Sanitaire, to select equipment and define details. Regardless of the tank type or shape, bulk flow is created by one or more mixers imparting thrust into the fluid. This thrust, which is in the form of a jet of water, moves the fluid and does the most intense mixing. Remember, when comparing mixers, consider only those tested to the ISO 21630 standard. This is the global standard for measuring thrust and will ensure that you are making a legitimate and valid comparison. Movement of the water depends on where the jet is positioned in the tank. If placed improperly, the jet will be less effective creating calm zones. This can be corrected by increasing the speed of the mixer or repositioning it. However, you will use more energy than required if the mixer is not positioned correctly. In addition to bulk flow, an intense amount of mixing is happening around the jet boundary. As the jet expands, it entrains more of the surrounding fluid. The jet gets wider and slower until it is moving the entire contents of the tank along with it, achieving an efficient bulk flow for effective mixing. Over the years, leading manufacturers like Flygt have developed advanced models for predicting the amount and placement of thrust required to achieve proper mixing for a wide range of mixing duties and applications within typical tanks. We can analyze the drag imposed by typical walls, turns, obstructions, and variations in the fluid behavior to determine the optimum thrust. Armed with that information, we can typically offer 3 or 4 different models to choose from for any given configuration, providing options for improved redundancy, lower capital cost, or lowest lifecycle cost, depending on your interests. Choosing the appropriate mixer is important. Today, however, most mixers are oversized for the job they are doing. This is usually because they are sized for the worst-case scenarios. The manufacturers use older or imprecise sizing models due to the lack of experience in the application, or the mixers were sized without adequate consideration for issues like pre-screening, sedimentation, and location of inlets and outlets in the tank. To help determine the appropriate mixer, you should look at 3 key parameters: mixer speed, the thrust it is generating, and the power it is consuming to generate that thrust. This information tells you how hard the mixer is working, how efficiently it is delivering the needed thrust, and of course, what it is costing in energy consumption. Remember to look to the international standard, ISO 21630, for unbiased thrust comparisons between mixers. Never settle for rules of thumb or unsubstantiated claims. A new world of possibilities opens up when you move to a mixer with integrated variable speed control, like the Flygt 4320. First, the power consumption at any given speed drops dramatically, thanks to the high-efficiency permanent magnet IE4 motor, combined with the mixing intensity optimized for the actual operating conditions, using integrated variable speed technology. Second, watch what happens when the mixer starts slowing down to meet the actual needs in the tank. Small reductions in speed and thrust come with much larger reductions in power. These reductions in power and speed also can extend the life of the mixer and the intervals between servicing. So when is it appropriate to slow the mixing speed? You must consider changes in flow through the tank, the total suspended solids, and even the total amount of wastewater in the basin. All these changes, whether they happen hourly, weekly, or seasonally, are opportunities to save energy and reduce your carbon footprint while extending service life and improving reliability. Variable speed mixers have other advantages as well. For example, the Flygt 4320 is equipped with advanced communications, so you know what is happening below the surface. The 4320 knows its speed, power consumption, temperatures, runtime, and more. And it communicates this information, along with any warnings or alarms, continuously via a variety of connected devices utilizing Modbus and other protocols. The 4320 can also tell if rags are building up on the mixer blades. The motor's integral speed control senses the excessive load and automatically backs off on the speed so the materials will fall off. Then it returns to normal operation without any need for human intervention. Finally, the 4320 can dramatically reduce inventory costs. Many wastewater treatment plants stock a number of different mixers because their various applications need different amounts of thrust. With the 4320, a single mixer can replace a dozen different size mixers. In the end, it's important to do your homework before choosing a mixer. Get thrust analyses from multiple vendors, and if one seems out of line, ask why. Remember, lower speeds result in less energy usage and less wear and tear on the mixer, and optimal mixing almost always costs less on a life cycle basis. If you have questions about mixer speed, the thrust it is generating, and the power it is consuming to generate that thrust, have an expert like Flygt run the numbers for you. By taking advantage of ways to mix smarter, you can save energy, boost performance and reliability, simplify operation, and reduce inventory costs.